Welcome to Coffee, Contractors, and Concrete, a podcast series focusing on all aspects of the surface preparation industry and brought to you by the industry experts at Buy Manufacturers Direct. Joining the podcast today is Substrate Technology President, Industry Patriarch, social media educator, and leading subject matter expert, Josh Jones. Kind of give us your definition as someone who's been in this industry for almost your whole life. How would you define surface preparation as of today? I know it's evolved over the years, but as it relates to today's industry, how would you define surface preparation?
The simplest way to put it would be to basically prepare a surface for whatever the coating needs in order to achieve maximum adhesion. When it comes to high performance coatings, because of the way that they react and they attach to the concrete in this case, I'm going to be preparing the surface based upon what that product requires. So surface preparation really is a big umbrella when it comes to the different ways I would prepare the surface. But basically, just to get the concrete in this case, as the substrate that I'm trying to bond to, completely ready to accept that resinous product.
Expand on that a little bit. A resinous product, so we're talking about coatings. I assume preparation is also something that would be critical to setting the base for polishing concrete as well.
In a manner of speaking, yes. It's actually a good point. Surface preparation, it can mean getting whatever is on the floor currently completely removed so something new can be installed. In the case, in your context of polished concrete, if I have a floor that currently has paint on it or vinyl tile or carpet or something else that needs to be fully removed, that also falls under surface preparation. That means that many different machines may be needed to get it to the point where it's ready to be polished. But there again, that's where, it's a difficult question to answer other than to say it's a big umbrella or it's a big topic when it comes to surface prep, because it basically has everything underneath it that has to do with what has to happen to this floor in order to get it to the new result that's desired.
So from your perspective, surface preparation is even more broad scoped and where it incorporates the actual removal of an existing floor covering, glue, adhesive, whatever's on there to expose the substrate, in most cases concrete, before you can start profiling or prepping the concrete for whatever the new application is going to be. Would that be correct?
Absolutely. I mean, if you just take as an example, a large retailer wants to switch from vinyl composition tile, VCT flooring. They want to switch from that to polished concrete. That means that the contractor, somebody is going to be responsible for removing the vinyl composition tile, the VCT that's in place currently, in order to achieve whatever the polish level may be that's specified. If I'm a contractor that is offering full surface preparation and polishing services, I have to have all the information necessary then to remove the flooring that's in place, which means I need to scrape and remove all that tile. I need to grind to remove all the adhesive. And then I, of course, need the chemistry and the diamonds to be able to do the polished result. So, yeah, absolutely. In the real world, if somebody needs to satisfy a contract and the contract is switch this floor from VCT to polished concrete, then I will be doing a lot of extra prep work that has nothing to do with polished concrete.
So again, to be fair, surface preparation is, again, many facets. It's removal, it's preparation, and then it could be, putting down a new coating. It could be polishing. It really is an A to Z process that is more than just going in and profiling a surface for something else. So I think that goes back to my main point. I think we've seen surface preparation expand in its scope over the last probably 15 to 20 years.
I think what it is, and maybe it's just an evolution of business and let's say accessibility and availability of equipment and knowledge to be able to use the equipment. It's very difficult to be successful, I think, as a contractor that's only niche services or only a specialist, meaning I don't know that somebody can stay successful only taking up adhesive or only taking up tile. So I would say the industry has kind of evolves from I am just a polisher to now I need to get a scraping machine. I need to get a grinding machine that's maybe dedicated to just these processes before I can do what used to be my plan, which was I'm only going to polish new concrete. In a perfect world, I could be the contractor that says I will only do new jobs. But the reality is there's a lot of work out there. And obviously the customers are prepared to pay the money. There's a lot of work out there for someone that can be a one-stop shop, a turnkey operation. In which case, this isn't an unregulated industry, but just sitting here looking at it from a distance, I'd say all of that falls under surface preparation, regardless of what it's going to be. I don't know that anybody could be successful just saying I'm going to remove adhesive as a living. I think there's going to always be more to it. And to the contractor's credit, they want to diversify their business and what their services are. And so that's really, to me, that's the industry's responsibility to help them be successful at that.
Let's take one step back. We're talking about surface preparation. Let's talk about the actual surface. Surface for you and I, 99% of the time, that's going to be concrete. You hear lots of different stories about concrete. It's hard, it's soft, it reacts differently under these conditions, under other conditions. Let's talk a little bit why concrete is different. Why is concrete, say in Florida, different than what you'd find in the Midwest? And what components make it different? And how does a contractor identify what kind of concrete he has before he starts the preparation process?
With regard to the contractor trying to identify the hardness or the abrasion resistance of the concrete or the density of the concrete, if it's a matter of a simple site survey, then the only way that I know of to be able to do that, that's as non-invasive as possible, of course, is to do some kind of a scratch test to the concrete. There is something to be said for sharing of knowledge that indicates, based on a region of the country, the concrete is expected to be soft. You mentioned how the different regions would have different hardnesses. It's not necessarily by design or by a plan. It's just the reality of the situation based on the aggregates that are available in those regions. So generally speaking, the Gulf Coast down in Florida, anywhere along the Gulf Coast, really, concrete is notoriously soft. And the reason being is because the aggregates in the sand that they use are softer materials. Those materials are what's available. It's too expensive to bring in, let's say, the good hard aggregates from Northern California. So when it comes to learning one's region and what's typical of the concrete they have, there is something to be said for that knowledge and having that experience to make that identification. But as far as a contractor visiting a site, the only way that I know is literally to scratch it. And the best way to do that and to do it in a quantifiable way is with what's called a Mohs pick test, which basically are individual little pieces of metal that are numbered that will give me an idea of how hard is it to scratch this, and then give me a value that I can write down and then address from the standpoint of how are we going to deal with this hard or soft concrete. But that's the only way that I know to quickly and inexpensively assess the hardness of a concrete slab.
And we'll touch on it in a later podcast of how identifying hard and soft concrete relates to the bond of diamonds you should be using in a grind application. But we'll touch on that a little later. Let's talk about moisture in the slab. I've also heard a lot of things about, especially if you're putting down a coating, that your moisture level, pH level, has to be within a certain parameter in order not to trap that moisture in the slab. And that could be because it's, again, the mixed design of the concrete. It also could be the age of the concrete. It hasn't had time to fully cure yet. Touch a little bit on that and the methods to test for that, and what could happen if you don't take those precautions in advance.
When it comes to moisture, and this is probably the most confusing part for contractors when it comes to deciding if something is officially too wet or the humidity is too high to coat or cover. The first question I ask anybody when they have a question about the moisture content of a slab that they're intending to do anything with is, how old is it? If it is years old, then obviously the water of convenience, whatever was there when the concrete was placed, is now gone. If somebody says 30, 60, or 90 days, then my concern would be that the floor, despite maybe what science says at 60 days it should be as far as fully cured or cured enough, my concern would be that based on the temperature and the ambient humidity is how much water of convenience is still present in that slab. The difference between moisture and water, of course, is one is vapor and one is liquid. Vapor in concrete, moisture vapor in concrete, it will almost always be there because there's always moisture vapor in the air. Water in the concrete from the mix, the water of convenience that was there to place it, if that has not fully evaporated, then there needs to be some kind of mitigating layer that controls the evaporation of the water that will want to and will one way or another leave that slab, because of course its humidity is so concentrated and so high, the air above it, the plastic layer of resin or floor covering between it, is not going to stop it. So that liquid will eventually leave that slab as a vapor to some extent. That's my very first question. And that's a question that a contractor can ask any site owner, anybody that they're trying to do a survey for. They can ask that question and find out when it was installed. So when it comes to moisture and concerns with that, that's the very first question I would ask. And I do ask when people ask me. The other question then would be, what is it reading? What is your product specifying? And if they don't know what it's reading as far as the ambient humidity or the humidity in the surface of the concrete, then that's going to be information that I would want to know as a contractor. Because if I don't know the relative humidity of the surface of the concrete, or maybe I do a probe test and I have a problem down the road and I have a failure, the manufacturer, one of the very first questions the manufacturer is going to ask is, did you moisture test it? And if they haven't moisture tested it, then they've really done nothing to protect themselves, and more importantly, to protect the reputation of the supplier who they buy from, to say that this wasn't a product failure, this was some other mysterious thing related to something not including moisture. But I would say the easiest way to answer the question about moisture and concerns that are related to it would be, how old is the slab, and is it going to be tested, or is there money in it? Do I have a meter? Do I have something that allows me to test, to take a real reading of the floor's moisture content, at the very least at the surface?
You mentioned product failure. So give me an example of a typical product failure. If the moisture if it's not tested and there's an issue. So what would happen to the product? Does it blister? Does it not have a strong adhesion? What are some of the clues a contractor should look for if that is indeed a problem?
Well, it would either be a product failure or an application failure. It's either when it was installed or it's the wrong product, was not done correctly or specified incorrectly. I am grateful to say that I don't know too many times people actually have a product that goes bad, meaning meaning everything that was necessary to be done for the product, it was specified correctly. The product just decided one day to stop working. And that's kind of what the manufacturer's position is too. They go to great lengths to make sure that their products are formulated and created in a way that is repeatable over thousands or tens of thousands of gallons of the material. When it comes to a failure, it's usually going to be a delamination, meaning it's flaking or peeling. It can also be so severe that it has what's called osmotic blistering, which is basically moisture that condenses, just like it does in the clouds. Moisture condenses under this layer of resin until it becomes liquid water itself. And as time goes on, that expansion and contraction, as that action takes place, starts to blister the coating so severely that sometimes the floor can be cut open with a knife and it will actually weep water, because the vapor is condensed at that point. But usually it won't hide itself for very long, because the problem will normally take place at the bond line. And most of these thin mill coatings that have this problem are no thicker than a credit card. And though they are a hard, high compressive strength material, when it comes down to it, it's still a sheet of plastic. So if there's enough water underneath it that's condensed, it will start to blister, it will start to peel, sometimes sheet off or just lift up, just like a piece of plastic. So that's really how it fails, is at the bond line, just below the level of the coating itself.
This concludes the first episode in a series of podcasts focusing on basic principles of concrete surface preparation. Make sure to join us for the second episode, where we discuss the iCRI CSP standards and begin to review the most popular methods of mechanical surface preparation. For immediate access to hundreds of tutorials and product information videos, we invite you to visit the By Manufacturers Direct YouTube channel. Simply visit buymanufacturersdirect.com and click Watch More Videos. New videos are posted weekly, so don't forget to subscribe and click that bell icon to be notified when we post a new video.